Stem cells are in general extremely fascinating because, as the name says, these are the primordial cells, the mother or father cells, from which a whole portfolio, so to speak, of different cells with different tasks arises.
Petra Reinke has a completely new task for these cells. She's a doctor and scientist at the BIH Center for Regenerative Therapies. Her goal is to give human cells to patients as a therapeutic measure. The idea to use healthy cells as a therapy is based on the possibility of obtaining stem cells and transforming them into different body cells. Since these are the patient's own cells, a later rejection response is prevented. Using the concept of ATMPs, Reinke wants to apply new methods to combat diseases still considered incurable.
ATMP is the acronym for Advanced Therapy Medicinal Product, a new class of medications that are typically cell-based. Here we isolate cells of interest from different parts of the body, from the blood, from tissues. We then allow them to multiply, genetically modify and stabilize them, and can then bring them back into contact with a variety of tissue types.
For patients, this would mean new hope for currently untreatable illnesses. The conversion of their own cells into ATMPs so that these cells can defend themselves against a disease in the body. An essential prerequisite for the production of ATMPs is the absolute purity of the treated cells that are later reintroduced into the human body. The technical term for this is Good Manufacturing Practice, or GMP. Stringent rules in the GMP laboratory prevent contamination of the cells. This includes a strict dress code. Every scientist in the clean room has to change clothes several times and put on an additional sterile bodysuit, so that no foreign particles or germs are carried into the protected laboratory. Absolute cleanliness is of utmost importance in the GMP laboratory because these cells are transplanted into patients and must not cause any side effects, inflammation, or new illnesses. The unique thing about a GMP laboratory is that the air in the room is extremely pure. By comparison, air out on the street has billions of particles, whereas here in the cleanroom laboratories, the air is 99.75% particle-free. In the GMP laboratory, immune cells are allowed to multiply and are then genetically modified or combined with specific biomaterials.
Today, one can also use different strategies to influence the effectiveness or the release of these cells.
Cells intended for patients undergo strict quality control in the laboratory. Further research on stem cells and immune cells, as well as on quality standards and the production of these new individualized medicines, is necessary before these cell therapies can someday become routine. But Petra Reinke is confident.
In principle, it's understood that illnesses have an actual chance to be cured with these therapies, unlike with pills that we take or with certain medicines that are called biologics. There, where we do not succeed in curing chronic diseases, these cells, with their diversity for different applications, have the potential to actually heal.